Welcome to the deep dive. You walk into a massive sports bar, look up at a wall of like 50 TVs, and spot your game. It's instantaneous.
Right.
But you probably never think about the sheer amount of data flying through the walls, just so you can, watch a punt on a 4K screen.
Oh, definitely not. And you really shouldn't have to. But if you peek behind the curtain or, in this case, into the server rack in the back room,
Yeah.
there is this massive, completely invisible infrastructure doing an incredible amount of heavy lifting.
Which is exactly our mission today. We are diving into some technical specs from HDTVSupply, specifically looking at their Atlona NETGEAR GSM4230PX managed network switches and the Wolfpack system.
Yeah, the Wolfpack systems.
So we're figuring out the crazy logistics of these multi-screen environments. Okay, let's unpack this. I'm trying to visualize this. It's almost like a giant digital traffic cop, right?
Yeah.
Seamlessly directing massive amounts of 4K and 8K video traffic to exactly the right destination.
Exactly. And what's fascinating here is the sheer scale detailed in the sources. We aren't talking about, just plugging a gaming console into your living room TV.
Right.
The sources detail systems handling up to 160 by 160 matrix setups.
Wait, 160?
Yeah, that is 160 different video sources being routed to 160 different displays simultaneously.
Which just completely blew my mind, because sending a web page or an email over a network, that's one thing.
Sure.
But uncompressed 4K video is incredibly dense.
Yeah.
I mean, standard internet traffic doesn't need to be perfectly in sync. If an email packet arrives a millisecond late, nobody cares.
Nobody notices.
Right. But if a video frame arrives late, the screen stutters or just goes black.
Yeah, absolutely. And to handle that, they use AV over IP, which is audio video over internet protocol.
Okay.
So instead of running a dedicated physical HDMI cable from every single cable box to every single TV.
Which would be a nightmare.
A total physical nightmare. They route everything over a standard computer network. The encoder takes the raw HDMI signal, compresses it, packetizes it, and the switch acts as this ultra-fast sorting facility.
Got it. Okay, so the hardware is performing miracles.
Mm-hmm.
But here's where it gets really interesting, because I have some serious pushback here.
Okay, let's hear it.
The person operating this on a Friday night is like a busy bartender holding a pitcher of beer.
Right.
Dealing with a dozen people yelling about changing the channel, handing them the controls to a massive blinking network switch without a computer science degree seems like a disaster waiting to happen.
Oh, it absolutely would be if they were actually interacting with the switch's command line.
Yeah.
But if we connect this to the bigger picture, the hardware is really only as good as the interface. The genius of these systems is how they hide the hardware behind a highly abstracted control layer.
Okay, so like the free Android and iOS apps or the Windows 11 software I saw in the specs.
Exactly. Or even the seamless DirecTV app integration. The bartender's just using a visual map of the restaurant on an iPad.
But mechanically, how does a simple iPad app instantly command a heavy-duty video network without lagging? I mean, all that heavy data.
Well, because the app isn't touching the heavy video data at all, when the bartender drags a game icon onto a specific TV icon on the tablet, it just sends a tiny lightweight text command,
Oh, I see.
an API call to the central processor. The processor gets that instruction and translates it for the switch. The heavy lifting stays entirely on the hardware, while the user interface remains incredibly light and responsive.
That actually makes sense. And that explains the advanced video wall processing too, right? Like they advertise picture-in-picture or picture-outside-picture.
Yeah.
Previously, you'd need a dedicated AV tech sweating over a calibration monitor to do that. Now the bartender is just pinching and zooming on a tablet, and the processor calculates all that pixel geometry in the background.
Exactly. And that absolute reliability, the fact that the processor and switch execute perfectly every single time someone taps a screen,
Yeah.
that is what opens up a completely different tier of usage for this exact same technology.
So pivoting a bit, looking at the catalog,
Yeah.
it goes heavily into government procurement.
It does, yeah.
They list federal GSA schedules, NASA CFP programs, and TAA-approved products.
Oh, yeah.
I get the sports bar scenario, but why does a TV switch need government-level procurement programs?
Well, this raises an important question about infrastructure security and reliability. Look at what those acronyms actually mean. The GSA, or General Services Administration, and NASA's CFP program.
Right.
Those are essentially massive government purchasing contracts that streamline buying for federal agencies.
Okay.
To even get on those lists, your hardware has to prove extreme reliability. It shows how this exact same technology bridges the gap between a local restaurant and high-level government facilities.
Wow. And I assume the TAA-approved part is a security measure.
Precisely. The Trade Agreements Act requires that the product is manufactured or substantially transformed in the U.S. or an approved allied country.
So no hidden backdoors.
Exactly. It guarantees there are no compromised ships from hostile nations, which makes total sense when you consider the stakes.
Yeah, a dropped packet in a sports bar means someone misses a field goal. But a dropped packet or a hacked switch in a military command center or a NASA control room? I mean, that's a crisis.
Exactly. The underlying architecture is exactly the same, but the hardware is just built to a fail-safe, secure standard.
So what does this all mean? I guess it fundamentally changes how I'll view those giant screen walls in public spaces. It's not just a TV plugged into a wall. It's a massive, secure logistical network operating silently in the background, making it all happen.
It really is. And it makes you wonder about the future of our own living rooms.
Oh, how so?
Well, as our homes get more connected with security cameras, multiple 4K streaming devices, gaming rigs, we are demanding more and more bandwidth.
Yeah, that's true.
So how long until the increasingly connected smart home requires a miniaturized version of these exact commercial-grade AV matrices just to manage our own daily media consumption?